Hey, it's Mr. Saltano. This video is going to be talking about atomic structure, so the structure of the atom. Before we get started, remember that there was a dense positively charged nucleus within the atom, right? Who was it that said that again? So that was Rutherford, right? Ernest Rutherford said that there was a dense positively charged nucleus. So that's what we're really focusing on, is what makes that nucleus that way in this video. So we now know that the nucleus contains protons, right? And who discovered those protons again? Well, that was Goldstein. Goldstein discovered the protons, and then also within the nucleus are contained neutrons. So who discovered the neutrons? Well, that was Chadwick. So we're reviewing these scientists here. Now we also know that around the nucleus now are electrons. So who is it that discovered those electrons? That was J.J. Thomson, right? And then this one we didn't focus as much on, but you should have seen this. The scientist who claimed that electrons orbit the nucleus like planets around the sun is actually Bohr. So the Bohr model is a lot more like what we see on more commonly of the atom. So this is what we're looking at over here, where these electrons are circling around the atom in certain orbits. So that was Bohr who said that. So we're going to go through exactly how to know how many protons, electrons, and neutrons there are within the atom. So the first thing you want to know really is the atomic number. And the atomic number of the element is the number of protons. It's always the number of protons no matter what. That's what the atomic number is, the number of protons within the nucleus of the atom. So it's like the ID. It's like a driver's license of the element. It tells you exactly the number of protons. And the number of protons is really who you are as an element. If you have a certain number of protons, you can only be a certain element. If you add a proton, you're a different element completely. If you remove a proton, you're also a completely different element. So it's very important that we know that proton number tells you your identity. Another important thing is, what is the overall charge of an atom? So what is the charge of just a regular atom overall? Well, the charge is neutral, right? So if we have a neutral atom and we have a certain number of positive charges, they must be balanced by negative charges, electrons, right? So because of that, there are a whole bunch of different things we can know just from knowing the atomic number. We can actually solve for a whole bunch of pieces of information. So let's see what they are. Well, for one, like we said, the number of protons is your identification. It's exactly who you are. So kind of like this police pulling over carbon. It's going to request a license and registration, right? So carbon would show its atomic number to prove that it is carbon. And that atomic number is your number of protons. So these are the three things that you want to be aware of. The four things, actually. One is that the number of protons is your identity. It's who you are as an atom. It's which element you are, essentially. That is your identity and your number of protons. Because your number of protons must be balanced by an equal number of electrons in order to have a neutral atom, that means that the atomic number can also tell you your electron number. So the atomic number is all of these things. So we look here at magnesium. Now, where is the atomic number on magnesium? And this is actually how it's represented on the periodic table. So the atomic number is right there at the top. So when you look at the periodic table, the number that's not a decimal will be the atomic number. And so only magnesium will have a 12 for its atomic number. If we had a 13, it would be another element altogether. So we now know that magnesium is 12. It has 12 protons, and it must also have 12 electrons, because that's what makes it a neutral magnesium atom. We'll get to this decimal number in the future. Okay, so chlorine. So here's chlorine. What is the atomic number of chlorine? What is the number of protons of chlorine? And what is the number of electrons of this neutral chlorine atom? Well, we can tell that the atomic number is 17. So therefore there are 17 protons, and there are also 17 electrons. Okay, take a moment, and you're going to need the periodic table for this, so feel free to pause and pull one up either online or if you have one in your binder or something. But take a moment to try to figure out what atom we're looking at here now. Keep in mind, here's our nucleus. The green and the purple are our nucleus, so the green are the neutrons, the purple are the protons. So there are 3 protons here. So that should be all you need to tell exactly what element this is. So the element is lithium. So lithium has an atomic number of 3. That's the only element this could possibly be, because your atomic number is your number of protons, which is 3. Okay. Now something a little bit different is called mass number. Now, according to Rutherford, where is most of the mass of the atom concentrated again? Well, we now know that that's in the nucleus, right? And so in the nucleus is where your protons and neutrons are. So your protons and neutrons are in that nucleus. And because of that, the mass number is based entirely on your number of neutrons and protons. So that's going to be important. Here's kind of a visual of that. So here's like our little tiny electrons. Here's our protons and neutrons that make up most of the mass of the atom. And so like we said, because of that, whenever you find the mass number, it's going to be number of protons plus number of neutrons. If we go back, it's literally just finding the mass of the atom that way. Just by counting the nucleus, basically, is how you find it. And the reason is because, remember, electrons have much, much smaller mass than either neutrons or protons. And so small, in fact, that we're not going to count them towards the mass number. So that's one way to remember that. So the mass number is the sum, so we're going to be using addition of the neutrons and protons. And if we use this equation down here, as long as we have 2 of those 3, we can actually solve for the last one. So the easiest way to think about that as well, protons, if we have protons and neutrons, we just add them together to get mass number. But what if we had mass number and then we only had protons? How do we figure out the number of neutrons then? So the answer is that we would just subtract, right? We would say mass number minus the protons is going to give us the neutrons. We could do the same thing for over here. We could do mass number minus neutrons gives you protons. You can really move that around however you want to. And so this is important because there are different things called isotopes, which we'll get to later, and that's when a certain element has different mass number. So for example, this is lithium 7, because it has 3 protons and 4 neutrons, and this is lithium 6 because it has 3 protons and 3 neutrons. So the number of neutrons is the only thing that changed. Remember, the identity is based on the number of protons, so we can't change a lot of things. We can only change the number of neutrons, really. And so your mass number for this guy is going to be 7, and your mass number for this guy is going to be 6. Again, all we did was we counted the total particles in the nucleus, and that's how we got our mass number. So the sum of the protons and the neutrons is the mass number. Okay, so now we're going to look at a bunch of elements and try to figure out the missing information. So for hydrogen, if this particular hydrogen has a mass number of 1, and hydrogen always has an atomic number of 1, figure out what the number of protons, neutrons, and electrons will be. Well, the number of protons is going to be 1 because of the atomic number, right? But the mass number is also 1. So we can tell that there are actually 0 neutrons there, and there's 1 electron because we have to have the same number of electrons and protons. Okay, let's try for helium. What do you think for helium? We have atomic number of 2, so that means protons should be number 2. But we have a mass number of 4, and so therefore we should have 2 neutrons there, right? And then we'll have 2 electrons to balance out the 2 protons. So that's what we have there. What about this lithium? Solve for lithium. So we actually have that. And what about this beryllium? So we can tell that this beryllium will actually have 5 neutrons and 4 protons and 4 electrons. And then for boron, take a look at it for a minute. Atomic number is 5, mass number is 11. That means that our protons is 5, electrons are 5, and the neutrons are 6. And then carbon is going to have a 6 all around. Okay, now let's work a little bit backwards. How can you tell actually what the atomic number of bromine is just by looking at our other information given? So in this case, we're going to go with the number of protons, right? Because that's the atomic number. So we put a 35 over here. The mass number is going to be the sum of the protons and the neutrons. So that's going to be 80. And that's what we have there. And then our electrons, of course, match our number of protons. Oxygen. Solve for oxygen. What is going to be the atomic number of oxygen? And then what's going to be the mass number? So we have 8 and then 16 because we add together the protons and neutrons. And then finally chlorine is going to be that. So that's it for us. So you really want to remember essentially the atomic number is the same thing as the number of protons, which is the same thing as the number of electrons in a neutral atom. The neutrons can actually differ from element to element of a certain, the neutrons can differ even if you have the same element. You can have a different number of neutrons, which we'll get to. And then you also want to remember that the mass number is the sum of the protons and the neutrons, because that's the nucleus. You only add up the nucleus, right? Thank you for watching. Remember, chemistry is everywhere.